We will now write the standard form of this quadratic function f of x equals 5x squared plus 20x plus 5. First, I'm going to factor 5 from the right side expression. So I write f of x, and this equals I factor 5. So therefore, 5x squared divided by 5 is x squared. And then when you factor 20 from 5, it's basically dividing 20 by 5, and this equals 4. So I write 4x plus I factor 5 from 5, so I have to divide by 5, and this equals 1. So I put 1, and this is the expression that we have on the right side multiplied with 5. And in the next step, we have to write down this expression, that is x squared plus 4x, as a square of a binomial. So I write down this 5. And for this, we have to take the half of this coefficient of x, which is 4. So the half of this equals 2, and we have to add its square, that is 2 square, and also subtract its square. So let me put that here. So therefore, I write x squared plus 4x. Now I add the square and also subtract the square. So I put 2 squared minus 2 squared plus we have this one. So we put this one. Now we see that we can write down this expression, that is x squared plus 4x plus 2 squared, as a sum of the binomial square, that is 5 times of, I can put this as x plus 2 quantity square, and we then have negative 2 square, which is negative 4 plus 1. Now let's simplify. So this equals, we have 5, and then multiplied with x plus 2 quantity square, and minus 4 plus 1 is minus 3. And so now in the next step, we can distribute this 5 into the terms inside the bracket. So therefore, we can write down this as 5 times of the binomial square, that is x plus 2 quantity square, and 5 times negative 3 is negative 15. So we have this f of x equals 5 times of x plus 2 quantity square minus 15, and this is the standard form of the quadratic function. In part B, we do the sketch of this function f. So here we have this function f of x equals 5 times of x plus 2 quantity square minus 15. And we can compare this function with the vertex form of the quadratic function, that is a times of x minus h quantity square plus k, where h comma k is the vertex of the parabola, and a is a factor which tells whether the parabola opens up or opens downward. If a is greater than 1, it opens upwards, and if a is less than 1, it opens downward. So compare this f of x with this vertex form of the parabola. We see that a equal to 5, and this means this is greater than 1. So this parabola opens upward, and we can also determine the vertex of this parabola. H comma k is the vertex, so here this is x plus 2. So when you compare this with this form, it's basically negative 2. So h equals negative 2, and k equals negative 15. So therefore we say that the vertex is h comma k, and this equals negative 2 comma negative 15. So first we put this, or we plot this point on the graph, that is the vertex of this parabola, negative 2, negative 15. And we also plot the y-intercept of the graph. For that, we just have to put f of x equals 0 and solve for x. And when we do that, we will get x equal to 5. And this is the y-intercept 0 comma 5. And we also know that since a is greater than 1, the parabola opens upward. So we know how the parabola looks like, and we can also create a table of points with some points for x and corresponding points for y, and plot those points, and we can graph the parabola. So here I have drawn the graph of the parabola using the graphing tool.